Welcome to Manifested Publishers.
Welcome back to our lesson. In the previous lesson, I gave you the assignment, and these are the questions I left you as part of the assignment. Therefore, I believe that you've done the questions and you've done them the correct way. Therefore, in this lesson, I will just go through some of them and see whether you've been able to answer them correctly. We're going to do question number 3, 4, and 5. I think now 1 and 2, those ones are so simple you can be able to do because they're just using the principle of what the examples you had given previously. Therefore, we start with question number 3. And the question number 3 is, a sample of a hydrocarbon of mass 51.2 grams was analyzed and found to contain 12 grams of hydrogen. If the formula of hydrocarbon is CXHY, then find the value of X and Y. Now, in this question, you need first of all to know what a hydrocarbon is. And the hydrocarbon is a compound of hydrogen and carbon elements. It is a compound of carbon and hydrogen elements. And therefore, if the mass of the hydrocarbon was 51.2 and the mass of hydrogen was 12.8, then you can now be able to get the mass of carbon by subtracting 12.8 from 51.2. Therefore, we will have carbon and hydrogen. The mass of carbon or the mass of hydrogen is 12.8. The mass of carbon will now be 51.2. You subtract 12.8. This is the mass. So 51.2. Subtract 12.8. This gives you 38.4. So the mass of carbon is 38.4. The mass of hydrogen is 12.8. And therefore, we now divide by the relative atomic masses. The relative atomic mass of carbon is 12. The relative atomic mass of hydrogen is 1. Therefore, 38.4 you divide by 12. This gives you 3.2. And this gives you 12.8. This is the ratio. That is the ratio in which carbon and hydrogen are combining. But that's not the empirical formula, because the empirical formula is the simplest whole number ratio in which the atoms of elements combine. And therefore, when we reach this level, we are now dividing by the smallest, 3.2 and 12.8. The smallest is 3.2. So now divide both sides by 3.2. This will get as 1, then 12.8 you divide by 3.2. This gives you 4. And therefore, this is the simplest whole number ratio. The simplest whole number ratio. And therefore, the empirical formula of this compound will be CH4. CH4, that is the empirical formula of this hydrocarbon. And therefore, the question was, find the values of X and Y. Therefore, X is equals to 1 because we have 1 atom of carbon, and Y is equals to 4. That is the values. Those are the values of X and Y. X is 1, Y is 4. That is how you're supposed to go about the question. I believe that you've been able to get the values of x as 1, the values of y as 4. If you have gotten x as 1 and y as 4, then well done. The next question is question number 4. The question number 4 is the empirical formula of an organic compound is C1H2O1, that is oxygen. Then if the empirical formula mass of the compound is 30, then find the percentage composition of elements in the compound. We're looking for the percentage composition. Then we have C1H2O1. The formula mass of the compound is 30. Therefore, because the elements which are forming this compound are carbon, hydrogen, and oxygen, then it will now be so easy to get the percentage, because the percentage, we start with the percentage of carbon, and the percentage of carbon will be given by the mass of carbon, which is 12, divided by the formula mass of the compound, which is 30. And therefore, because we are calculating the percentage, then you have now to multiply by 100. Then the percentage of hydrogen will be, the hydrogen has a mass of 1, but there are 2 atoms of hydrogen, then it will be 2 divided by 30, then you multiply by 100. And lastly, it is oxygen. Mass of oxygen, or the relative atomic mass of oxygen, is 16. You divide by the relative formula mass, which is 30, and multiply by 100. So the mass of carbon will be 12 divided by 30. This gives you 0.4. When you multiply 0.4 by 100, then you get 40%. So 40% is the percentage of carbon in that compound. Go to the next is hydrogen. This is 2 divided by 30, which is 0.06. Then you multiply by 100. It gives you 6.667%. Then oxygen, this is 16 divided by 30. Gives us 0.533. Then multiply by 100. Then it will be 53.333%. Therefore, those are the percentages of carbon, hydrogen, and oxygen. When you sum them up together, they are supposed to give you 100. Therefore, 40 plus 6.667 plus 53.333, then they're supposed to give you 100, because there are 3 elements. Three elements in this compound. The mass is 30. Then you get the relative atomic mass of each element. You divide by the formula mass. Then you multiply by 100. And then these are now the percentages. Question number 5. Question number 5 is, in an experiment, 3.10 grams of a compound of carbon, hydrogen, and oxygen produced 4.4 grams of carbon dioxide and 2.7 grams of water on complete combustion. Then determine the empirical formula of the compound. Then this is because you don't have the mass of carbon, I don't have the mass of hydrogen, then you have now to look for them in carbon dioxide and water. Therefore, mass of carbon you'll get the mass of carbon by, you thought the relative atomic mass of carbon is 12. Therefore, it will be 12. 12 we divide by the relative, or the relative molecular mass of carbon dioxide. Carbon dioxide, the molecular mass, this is 12. The mass of carbon is 12. The mass of oxygen is 16, then times 2 atoms. Then this now gives you 12 plus 32, which is 44. So the relative formula mass of, or the relative molecular mass of carbon dioxide is 44. Then now this, you are multiplying by 4.4 grams of carbon dioxide. It's 4.4 grams of carbon dioxide. Remember, the aim is to get the mass of carbon in carbon dioxide gas. The mass of carbon in carbon dioxide gas. And therefore, this will be 12 divided by 44. You multiply by 4.4. You'll get this as 1.2 grams. That is the mass of carbon. The next, we need to calculate the mass of hydrogen from the water. The mass of hydrogen. And the mass of hydrogen is given by, this is the formula of water. Then the relative formula mass is 1 times 2. That is the mass of hydrogen, plus mass of oxygen is 16. And therefore, this gives you 2 plus 16, which is 18. And therefore, the mass of hydrogen here will be 2 over 18. Therefore, this is 2 divided by 18. It is 2 because we have 2 atoms of hydrogen. 2 atoms of hydrogen. So 2 divided by 18, then you multiply by the mass of water, which is 2.7. And that you'll be getting as 2 divided by 18, you multiply by 2.7. You'll get that as 0.3. 0.3 grams. 0.3 grams is the mass of hydrogen, and 1.2 grams is the mass of carbon. Is the mass of carbon. Therefore, what we don't have now is the mass of oxygen, and the mass of oxygen will be given by you're told that in an experiment, 3.10 grams of a compound of carbon, hydrogen, and oxygen. We already have the mass of carbon, the mass of hydrogen. So whatever we don't have is now the mass of oxygen. And we are told that the mass is this, 3.10 grams. Therefore, it will be 3.10 grams. You subtract 12, not 12, but 1.2 plus 0.3. That is now the mass of carbon and the mass of hydrogen. This is 3.10 minus 1.5. And it will give you It's giving you 1.6 grams. 1.6 grams, that is now the mass of oxygen. And therefore, if you are now determining the empirical formula of the compound, therefore the empirical formula, you'll have the mass of carbon, or you'll have, the empirical formula is having carbon, hydrogen, and oxygen elements. The mass of carbon is 1.2. The mass of hydrogen is 0.3. And the mass of oxygen is 1.6. Therefore, we divide by these are masses. We divide by the relative atomic mass. The relative atomic mass of carbon is 12.0. The relative atomic mass of hydrogen is 1.0. And this is the mass of oxygen is 16.0. Therefore, in the first case, 1.2 divided by 12, it is 0.1. This is 0.1. This is 0.3. This is 0.1. Therefore, in that case, again, you divide by the smallest. Therefore, this, you have gotten this as a ratio. This is the ratio in which carbon, the carbon, oxygen, and hydrogen are combining. You divide with the smallest, and the smallest is 0.1. So you divide all of them by 0.1, divide by 0.1, and divide by 0.1. Therefore, the ratio will be 1, 3, then 1. Then this is the simplest whole number ratio. That is the simplest whole number ratio in which carbon, hydrogen, and oxygen are combining. 1, 3, 1. And therefore, the empirical formula is CH3 then O. That is the empirical formula. That is the empirical formula of a compound of carbon, hydrogen, and oxygen. It is that simple. That is how you're supposed to go about the 3 questions. If you have done them like that and you have gotten them, then well done. Then I'm going to leave you with 2 more questions. You try them out also. That is the assignment. Question 1. A 9.6 grams piece of clean magnesium burned completely in 6.4 grams of pure oxygen. And the product was allowed to cool to room temperature and pressure, RTP. RTP stands for or represents room temperature and pressure. Then determine the reaction mole ratio and hence the formula of the oxide. The relative atomic mass of magnesium is 24.0 and oxygen is 16.0. Second, a sample of anhydrous copper 2 sulfate on analysis was found to contain 6.4 grams of copper, 3.2 grams of sulfur, and 6.4 grams of oxygen. Determine its empirical formula. The relative atomic mass of copper is 64.0, sulfur is 32.0, and oxygen is 16.0. Therefore, ensure that you've done the two questions together with the other two other questions were not done in the previous lesson, so that you have a better understanding of the empirical formula and how to calculate the empirical formula. In the next lesson, we will learn the molecular formula. We are now through, if you just do those questions, then you'll have now had enough practice on the calculation of empirical formula. Therefore, next lesson, we are going to learn about the molecular formula, and let's meet in the next lesson.